Hello and welcome. This is Cody, your dear loved engineer. Good evening so far. This is Python 0 for everyone who has absolutely no clue at all what a Python is and thinks it is a snake. Okay, it is a snake officially. But it is also a very awesome scripting language, and for me as an engineer, I tell you, it really hooked me up when I started using it for my PhD, because I got very, very productive once I used it and got pretty far with mathematics and stuff like this. So I want to show you this little gift from God to us. And yeah, let's start here an interactive Python shell. I will show you today the most basic data types, okay? So this is for everyone who has really absolutely zero clue about programming. I will start here from 0, 0. Maybe that's the reason why it's called Python 0. Yay. Yeah, it's pretty late. I tell you, this is gonna getting really, really funny. And I tell you, I've just drank alcohol-free beer. I'm a German. We got pretty good alcohol-free beer, but sometimes I have the feeling that it's not so alcohol-free like you always think it is. So let's get started with the... Oh man, I'm bragging too much. Let's get started with the most basic data types. There are pretty much three basic or primitive, I would call them. And they're strings. Okay, so strings are just text data, and you assign them to a variable with an arbitrary name by equal sign and then the double quotes. And if you print them here, you can also do print A, by the way. You get out the A, what's inside. You can see here when I want to print the object directly in this shell in a script, this won't work. Then you see the single quote and you see, okay, but you use double quotes, dude. And then I say it doesn't matter. Python doesn't matter about single or double quotes. Other programming languages do. Now you can also access with these square brackets here entries of the string, and you can also do it yeah, until like ranges. You start and this is the end, but you can also leave this aside, you know. It's pretty much simpler to do this. The first one is inclusive, the last one is exclusive. Okay. So these are strings. I will do my next tutorial video about it, because this is really getting you productive. Like handling strings, being fast with them, you know, reading files, manipulating them. This is what helps you most in the beginning, I think, and I will do it for my next video, so you can get started very, very fast. Now, there are more data types, like you can either choose full numbers, which are called integers, or you can choose, I don't know, yeah, don't use data type names for variables, because you will override them. Or you can simply do with a comma, you get a floating point number. Programming languages distinguish between floating point and non-floating point. This is due to the reason that in memory it's different. And you can imagine, like, use integer numbers for counting, okay? Because you always want to use them full numbers. And use floating point for math stuff, okay? You can also, it really doesn't matter, you can still cross them and add them, and if one of those is a float, it's converted to a float, by the way. This is one of the nice things about Python, is a lot of casting here, which is going on. Now, this is one of the traps. Dudes, I had like 4 days ago I had this bug. I still hit it. Not bug, like, yeah, it was a bug in my program, because I was dumb enough forgetting it again and again and again. If you divide 3 by 4, you would say it's 0.75, but it's actually 0. This is due to the reason that these are full integer numbers, and you know, they round off. So 7 divided by 4 should be 1. Yeah, it is. If you just do one of those with a dot, then it uses floating point division. In Python 3 it is fixed. It always uses floating point division. And yeah, integer division is enforced by double slashes. But this is already too much for you guys. just important to mention because this is gonna happen to you someday if you use 2.7. I tell you, it happened way too often to me. Now the last thing to do is maybe talk about assignments. So we have T1, which is assigned with value 3. And now what happens if we assign T1 to T2? Okay. The question is, of course, in both is the same inside. It's a 3. But what happens if we change T2, okay, to 4? And I tell you, it won't change, okay? So T1 is still 3 and T2 is 4, because what happens here is a copy, okay? So you copy the value 3 into this new variable, and they're both totally independent from each other in memory. And this is the most important note you should take from this step is this only applies to basic data types or primitives, which are integers, floats, and strings, okay? They are all copied. For more complex objects, and you will see it in a second, this does not apply. You don't have a copy here, you pass on the reference and can you manipulate the second object. This is due to the reason that objects may be large in memory and you do not want to create 1 trillion copies because your memory will be exhausted pretty much in a few just operations when you use a lot of memory. And I tell you, I use a lot of memory. I'm so happy that it works this simple way. Now, there are more complex data types, and the most important one are lists. You can initialize them either by the list function or like how I like to do it with these square brackets, and I love these square brackets for a major reason, because you can already throw in the numbers if you like to. Here we go. Yay, 1, 2, 3, 4, 5. And like in strings, you can also access the members. Yay, it's already way too late. No more alcohol-free beer for me, so late. Yeah, you can throw in an index, like for strings, and you get out whatever is inside here. So you can put in anything you want here. I asked for the 3, which is 0, 1, 2, 3, and 3 is the 4. You get out the 4 for the 3. Lists always, or whatever in Python, they start counting from 0. Okay, 0, 1, 2, 3. These are the indexes. You can expand them by adding in new whatever function values. And you see by this append function, you just call .append. You see it takes an argument, I know it, and I throw in an 8 and it's appended to the list. Now, the main question is at this time, what functions do we have for objects? And there are 2 ways to find out. The first thing is ask Google, because I tell you, if you don't use Google, you will never be a programmer at all. I cannot imagine how they did it in the old times, but I'm Googling like the hell out of me every day. Some insane Russian programmer always solved some crazy problems which I had in 1 line. I don't know. So this is the documentation of lists, and you can see there is a few functions, and of course the first one is the append, which I used here. There's also a very second helpful stuff. You can just write here help, and it will open a text, and you can see all the functions here. It's called methods here, and you will first be confused because you see, what is this underscore? Why did they put it here for these functions? I don't know. This is so confusing here. So first, let's get down, and you see, there is our append function here, which I just mentioned. Now, the question is, what are these whatever underscore operations? And I will show you. Let's say we have we assign a list. Let's put in some values. Maybe some unreasonable values, because then it's not so confusing. And you can, for example, combine 2 by calling the add function. Okay, I know it was inside. You could, if you scroll back, you will see it. And then what happens is it appends itself to itself. Yeah, Pretty funny. Oh man, this is getting hilarious here. I tell you, I shouldn't be listening to these funny music while doing these tutorials. Now, you can see it's just appended to itself, and this function looks pretty strange, and this looks so strange because it's just overloading the plus function. So you can also use just instead of add this plus function, and these other strange functions, you can do a lot of stuff. I don't know, like one is for double equals, which is comparison, and of course I'm equal to myself, and it returns true. Yeah, that's the way lists work, and also these functions work if you ever encountered them. Now, there is very familiar to lists, there are tuples. Okay, so tuples, they're working the same way. Okay, so you have you initialize them with these round brackets, and you can also get out the entries. But very important is you have no append function. They're fixed in size, so you cannot change the size. Just use lists in the beginning. Don't care about tuples. You will get familiar with them later automatically. Okay, so don't worry about it. Just use lists. Now, let's get back to our memory problem from before. You remember that when you do an equal sign, you kind of copy it over. Now, let's say we take this list and we take my list2, which is assigned to my list. Now, again, in both is the same inside, but what happens if we append to my list2 value minus 111? Of course, my list2 has this value in the background, but also I can tell you my list has changed. And this is the very, very important memory note I want to give you. For complex data types like lists, everything which is not a primitive, like not a number or a string, there's always a transfer ship here of reference. Like you copy over only the reference to the object, but not the content of the object. Very, very important, because most tutorials, they don't tell you, and like I said, it can totally crush you in the beginning if you don't know how memory is working, because in my sense, this is the most important thing for a programming language, is how the memory is working. Now, we had it with lists. There are two more data types I want to show you. Let's say we make a list. Let's create another one. I mean, I can pull off this for all night, which are called sets. And you initialize them by these round brackets. And because I want to initialize it with these list values. And the difference between a list and a set is, a set, you see it looks almost the same. A set, it has unique entries. Okay, so every entry is unique. You see, we had double ones here, but 1 is gone. 1 is gone. This is getting pretty nice today. I don't know what's going on with me. Yeah, but I hope you get the lesson so far. Yeah, so we lose 1, and that's totally fine, because sets, like I said, have unique entries. But what is also very important is you don't get out any. You have no indexing; it's unsorted. Okay, so you can still iterate over the entries if you want to. Okay. So you still get through, and here it's in order, but don't expect it to be in order in general. But if you want back the entries, like you wanna, let's say you have this very long list with 10 million entries, and you want to remove duplicates, and you can simply do this by doing first you do a list, okay, and then you convert it to a set. Okay, so you have the unique numbers, and then you convert it back to the list. And you see you have unique numbers inside, and what you really want also back is you get indexing back. This is very common technique for removing duplicates. Yeah, it's really handy because if you have to implement this yourself, it's really nasty. I can tell you. When I was young, I did a lot of dumb stuff, including such operations, removing duplicates from lists, I tell you. Okay, now there's one more data type to cover, besides tuples, lists, and sets, and they're called dictionaries. Okay, so in a list, you have arbitrary entries, okay, and you have indexing. So for an index, you get out the whatever is inside the object. Now for dictionaries, they work in a little bit more general way. So you can initialize them either by this dict function or these brackets. I like the brackets more. I like brackets. I tell you, these brackets are awesome. Really, there are so many types of brackets, and I always ask myself why, and now I found out it was just meant for Python to come up and use these brackets, I tell you. Now, you can, the really cool thing is, okay, you can do the same thing, like you can assign to this index 0 this value from before, okay? So it's working now currently like a list. You see here the 0 here, the index 0 is assigned with this value, but which is exactly the same like here on top. But the really cool thing is you can assign it with any key. Okay, so you do not have to use a number. You can also make a lookup by a string, or those both can be arbitrary objects. Okay, so you can make a lookup by either string or more complex data types. It really doesn't matter. And this is the really, it looks more general because here you only have numbers, but here you can have numbers, but also you can have strings for lookup. And by the way, maybe that's called a dictionary because dictionaries are used for lookups. They're more commonly known as maps in many different programming languages, but here they're called dictionaries. I don't know, I don't care. A name is a name, and life is a game. So dictionaries, the question is, why don't we just use dictionaries if they can do what lists can do? Yeah, it's not the same. In memory and how it's working and how fast it is under certain circumstances, it makes a difference. So if you have just indexing, use a list, and if you really need these dictionary functionalities, use a dict. Okay, so these were the basic data types. I really want to thank you guys for listening to me on these late hours. I hope you survived it. Yeah, it's. I tell you, alcohol-free beer, German alcohol-free beer, it's dangerous. It's also dangerous drinking too much of it. I'm sure it's also having its side effect. Next video I will cover as topic, like I said, strings, and show you how to get productive, because it's very important for me that you guys get hooked up pretty fast and can use these techniques in the scripting language. Because this is really, like most tutorials, they show you a trillion billion times how things are made up, but I mean, you cannot do anything now, and that's okay, because you should know this. But I think this is more than enough basics. The next time I can already show you how you can achieve automation with this. Okay, have a good evening, night, good morning, or whatever.